this lesson, we're going to look at the ambiguous case of the sine law. I'm going to put that up here, the sine law. And this occurs when you are trying to solve a triangle. I'm going to write this out for you. Trying to solve a triangle, but you are given two sides, two adjacent sides, and one angle. And that angle is not between those two adjacent sides. And this can cause problems because there are several different cases. So I'll show you the typical case first, and then I'll show you some of the others. So case one, this is just a regular triangle. So case one. So suppose you are given that side A is 12, side B is 10, and angle A is 30 degrees. So if we draw our triangle here, this is A, this is our 30-degree angle. This is side A over here, and this is, we'll call this B, C. So here B is equal to 10. Now here A, we have possibilities, different possibilities to draw it. You'll notice that A is greater than B. So this length here is greater than that length there. So this is A equal to 12. Now let's take a look and see what angle B is using the sine law. So we know that sine of angle A over side A is equal to the sine of B over side B. This gives us 10 sine 30 over 12 is equal to sine B. And if you calculate this out, this gives you 5 over 12 sine B. And then take the inverse to find the degrees. So sine inverse of 5 over 12 happens to equal 24.6 degrees. So this angle here is 24.6 degrees. Now we can easily find this angle using the law that the sum of the angles in the triangle sum to 180. So this is fine. This is a regular use of our sine law, but this doesn't always occur. So let's take a look at some other examples. So case two. This is where no possible triangle is given. So we have angle A is equal to 30 degrees, side A is equal to 4, side B is equal to 10. You'll notice how small side A is compared to side B. So let's draw our triangle here. This is 30 degrees. This is A, B, C. So side B is equal to 10. Side A is equal to 4. That's very small. Now let's see if an angle here exists so that these two lines here can touch to form a triangle. So again, we know that sine 30 over 4 is equal to sine B over 10. So 10 sine 30 over 4 is equal to sine B. Now, if you calculate this out, this becomes sine B is equal to 1.25. And this will give us an error when we take the inverse of this, because this can't be greater than 1. So this is undefined. Let me write it this way. This is equal to undefined. It can't exist. So no triangle exists in this case. So there is no triangle. Side A is too small in this case. Okay, case 3. So let's suppose now we have angle A. Let's keep it at 30 degrees. And side A is equal to 5, side B is equal to 10. Now notice this is smaller than B, but let's take a look at what happens when we create our triangle. So this is 30 degrees, A, B, C. A is equal to 5, B is equal to 10. So again, sine of 30 degrees over 5 is equal to sine of B over 10. So 10 sine 30 over 5 is equal to sine B. And when we take the inverse here of this happens to equal 1. Sine inverse, this gives us 90 degrees. So this happens to be a 90-degree triangle. Okay, there's one more case here that I'd like to go over with you. And let's go down to here. So now let's look at case 4. So here we're going to have angle A is equal to 30 degrees again. Side A is equal to 12, so it's larger, or sorry, side B is equal to 10, so side A is larger than side B. Oops, I think I just did this one, sorry. I did that one first. Sorry, let's do a different one. This is where B is 10 and side A, is 7. There we go. Okay, now let's draw our triangle here. So here is our 30-degree angle. This is A. Now, when we go to draw, here's B is 10. When we go to draw A, side A, notice here that I could draw this either like that or like that. And this would be the same length. So this is a length of 7. Now, if I draw it here, I'm going to call this B and find this angle here. Let's take a look at what that would be. So sine A, sine of 30 degrees over 7 is equal to sine B over 10. So 10 sine 30 over 7 is equal to sine B. This happens to be 5 over 7. So 5 over 7 is equal to sine B. And when we take the inverse of this, 5 over 7, this happens to equal 45.6 degrees. So this is this angle here, 45.6 degrees. Now, you'll notice, though, that this triangle here could exist where this is a oblique angle. This is an acute angle. So here, it is possible for this angle, this triangle here, to exist as well. This angle here would be 180 degrees minus 45.6 degrees, or 134.4 degrees. So this has two triangles, two possible cases. Two possible triangles in this case. And those are the cases you have to look out for to determine the solution for the triangle.